guys, Miss Rios here. This week we're talking about landforms. That is TEK 5.7b. That's your 5th grade TEK. Recognize how landforms such as deltas, canyons, and sand dunes are the result of changes to the Earth's surface by wind, water, or ice. And then we have some supporting TEKs. That's 4.7b. Observe and identify slow changes to the Earth's surface caused by weathering, erosion, and deposition from water, wind, and ice. A couple of things that I really like about that 4th grade TEK is it says slow changes. That's something that you really need to remember. The formation of landforms is a slow process. It takes place over millions of years. While sometimes it can happen rapidly, but most landforms are going to take a long time. So I like that word, slow changes. Hopefully you remember weathering, erosion, and deposition. Those are some of our vocabulary words that we've already gone over this week. Remember, weathering breaks it, erosion takes it, and deposition drops it. And then the three forms that are utilized by weathering, erosion, and deposition are water, wind, and ice. So hopefully all of that is kind of a review for you. And this week we're going to be looking at how weathering, erosion, deposition utilize water, wind, and ice to create landforms. And those landforms are deltas, canyons, and sand dunes, and how water, wind, and ice can change the surface of the Earth. So hopefully some of those words are familiar to you, and then the rest we're going to kind of talk about. Canyons. Thankfully, we live in a place where most of you guys have been to Palo Duro Canyon, so you're familiar with canyons and kind of how they look. They are a deep divide between steep slopes or cliffs formed from weathering and the erosion by moving water of a river over a long period of time. So the largest canyon in the continental United States is the Grand Canyon. It's really big, and it was formed by the Colorado River. So millions of years ago, the land on top of the canyon was completely flat. And once water started to run down across the surface, the Colorado River started to flow. It began to weather the rocks. So it began to break down those big rocks. At the same time as it was breaking down those big rocks, it was eroding away or taking away any kind of small sediments that were just kind of on the surface level of the Earth, and it would just kind of take them away. And after millions of years, you have this huge, gigantic canyon that formed. The exact same process happened for Palo Duro Canyon, and most of you have probably been to Palo Duro Canyon, so you're familiar that as you're driving into the canyon, it's very steep, so you know that those walls are very steep. A lot of times there's caution falling rock signs because the walls are so steep, and the road is very windy, but Palo Duro Canyon was created essentially the exact same way as the Grand Canyon was. So the Red River cut the Palo Duro Canyon, and when we have enough rain, the Red River flows through the Palo Duro Canyon, and you can see it, and you can fish in it. But what it does is it breaks down, and it took a long time to break down those rocks, but it breaks those down, and then as those rocks break down, they turn into tiny little pieces of sediment that then erodes away. So that's how the water kind of cuts those canyons, and it picks those pieces of sediment up and it erodes them away. And then when the sediment gets too heavy or the river's not flowing fast enough, then it drops it, which is deposition. So here is kind of a picture of a pretty typical canyon. It's got those steep wall sides. You don't see any water in this picture, but any kind of canyon was cut by water, so you can kind of assume that that riverbed is at the bottom. And you can probably, if you could touch those rocks, they would feel kind of grainy, maybe even kind of soft, because the water has a tendency to just kind of smooth things over. But that's kind of how a canyon is. These are some pretty typical pictures of canyons. You can see all of them have water in it and moving water. And all that water does is it breaks down the sides of those large rocks. It erodes away those tiny sediments, and it deposits them at another location. And all of these pictures you can kind of see, except for that top one, it doesn't look like there's water, but the little person that's in there, he is walking in what was the riverbed. But you can just kind of see that's how those canyons were cut. Very steep sides, that's going to be indicative of a river that has cut a canyon, very steep sides. Valleys. Okay, now canyons have real steep sides. You can kind of walk through them and everything. Valleys, as you can see, you can almost kind of live in between them. They're in between. They're the low-lying areas in between sloping hills or mountains. So as the mountain comes down and before a different one starts up, that's the valley. And weathering and erosion by a river or moving water or a glacier over a long period of time form these valleys. Now, there's two different types of valleys that we're going to talk about, and they're very indicative of their shape. So the same way that a canyon is cut by running water and the sides are very steep, that's the same way with a valley. You can kind of see this picture right here. The sides are not very steep, and if you were to take your finger and kind of trace it, start at the top left-hand corner of the green part where that mountain is, and you kind of trace it down, and then you can kind of come all the way around to the other side. It kind of forms like a U. Those are the two different types of valleys. So U-shaped valleys are carved from very, very, very slow-moving glaciers. And glaciers are these huge bodies of ice, essentially. And they start off at high levels of elevation, okay? So they're very high up on mountains, high levels of elevation, and then a force, gravity, starts to pull them down because as they accumulate more mass, as they become bigger, gravity pulls them down. Now, because they're so large, they're so slow moving, they come down at this very, very, very slow rate. A lot of times it happens so slowly that the water kind of melts and refreezes. It picks up rocks, larger rocks. It picks up small pieces of sediment as it kind of cuts its way literally down the mountain. So glaciers have a really unique way of really kind of slicing through mountains. It's very slow moving, but they pick up or they erode away a lot of sediment, and they carry that with them as long as they're intact. They also break down rocks or weather them, and they can cut through very, very large rocks because glaciers are so large. So they're able to really kind of cut through these mountains. And then as they get into the lower lying valleys, as they come down from that high elevation, the temperature changes. So very high up, it gets very cold. As they come down the mountain and gravity is pulling them down, it gets to be where it's warmer. And what happens when ice warms up? It starts to melt. So as they kind of cut these valleys, eventually there comes a point where they kind of melt. And that's how you have these great big U-shaped valleys that you don't see a glacier there, but that's how it was cut because of these U-shaped valleys. And you can really kind of see the difference in them. The V-shaped valleys are formed by rivers. So if they have kind of higher sides and it looks like the valley has a little bit more of a V shape to it, then that's going to be cut by a river. And here are some pictures of both V-shaped and U-shaped valleys. You can really see the difference in them. The V-shaped valleys have a lot higher sides. They're a little bit steeper, probably not a place where you could build anything, but you can, and in the bottom left picture, you can see the river running through it. The U-shaped valleys is going to be more indicative of the glacier. The glacier kind of cut through it, but that place at the bottom is probably very capable of supporting a house or a small town or any kind of livestock or things like that. So people tend to live in these U-shaped valleys just because the land is a little bit more hospitable because it took such a long time for them to form. Sand dunes. Sand dunes, whether you are in a desert or on a beach, they kind of form the exact same way by wind. So they're mounds of sand formed by erosion and deposition when wind blows. So, essentially, you guys know sand. It's very, very small pieces of sediment that have been weathered by larger rocks. So these rocks can be weathered away by waves. If waves are crashing into a shore, into these cliffs, then the waves are slowly weathering and breaking down those rocks and turning those big, large rocks into smaller pieces of sediment, which are then deposited on the beach. So now you have sand. Also, sand can form, 100 miles away. Sand it's very small. And it can, stay in the air for long periods of time. As long as the wind is moving fast enough, it can keep any kind of small sediment into the air. So sand dunes can form from sand that was created right there on the beach through weathering with the waves, or it can have kind of blown in from a different place where wind or ice or something has weathered those rocks, and now the sand is kind of blowing in. Dunes form by big gusts of wind kind of blowing this sand and then depositing it in large piles. So you guys are probably familiar with that. You've been to the beach or you've touched sand, and you've probably pushed sand into kind of a big hill. That's kind of the process of it. You kind of, the wind blows it into large piles. It takes it takes weathered pieces of rock, which is the small sediment, which is sand, and it erodes them. The wind erodes them and deposits them into these large hills on a beach, which is essentially sand dunes. And it's the exact same process, in a desert. The wind is going to deposit sand into large hills, and then, if it's windy, it's going to pick it up and blow it somewhere else. So sand dunes are very mobile. They're changing constantly, particularly in high windy areas. But the process is the same. So here are some pictures of some sand dunes, and in the top left one you can kind of see the wind blowing those pieces, how small it is and how much of that sediment can get caught up in the air. It really does not take a lot, and if you've ever been to the beach and it gets windy, you probably felt little pieces of sand kind of crash into your legs. It kind of hurts a bit because it's abrasive like sandpaper. So these little pieces, they don't have to come up in these big chunks. They come up in very small pieces of sediments, and they move into these sand dunes. Okay, deltas. Deltas are one of my favorite landforms. I'm kind of partial to the way they look. I think they look really super cool. I like deltas, and they always form in the same manner. And if you're looking at this picture, they kind of fan out. And I think that's why I like them, is because they remind me of one of those fans that you probably had as a child, where you could make it really skinny, and then you could unfold it, and you could kind of fan yourself, and then you could, bring it back together, and it was really tall and skinny. And so I think they look really cool. But deltas are formed by deposition. All right, so they deposit sediment that's carried by a river as it enters slow-moving water or sitting water. Okay, so when you're thinking about a delta, you have to think about where the river starts. Most rivers are going to start at a higher elevation, so they're going to start up a mountain, and they're going to move towards large bodies of water. Gravity is going to pull them down, okay, down a mountain, down a hill. It's going to kind of pull them down. And if you think about it, you know that a river going downhill is going to move faster than a river on flat land. Okay, so think about it like that. So deltas form when the water gets slow and still. As water moves into a larger body of water, so rivers, they're always dumping in their contents into larger bodies of water. So the Mississippi River, it cuts almost the United States all the way down, but it eventually deposits into the Gulf of Mexico. And so as it moves down, it picks up and it erodes sediment away in the river. And as long as the river's moving really fast, the sediment stays in the water. But as it starts to slow down, the river loses a lot of its momentum, and it cannot support heavy or pieces of sediment that have a lot of mass. So it deposits them. Okay, but rivers are always, for some reason, very anxious to get to the ocean. They're very anxious to dump their contents. And so as they start to deposit these pieces of sediment, the land changes and kind of gets bigger, and it doesn't allow for the river to flow. It slows it down even more. Okay, so then it starts to branch off, and that's why you get all these kind of tiny little rivers that branch out, and they're trying to get to the ocean as quickly as possible. But that's kind of what they're doing. As they drop the sediment, the land changes, and the river can get narrower. And then it just causes the river to spill out and go in a different direction as it's trying to make its way to the ocean. So as you can see, particularly in that top left corner, that's the Mississippi River that we were talking about, and it flows through Baton Rouge, and you see it's very windy, but as it starts to get to about New Orleans, it's going to start slowing down, and then you'll see that modern delta. You see how there's always these little kind of ways for the different paths for the river to kind of get out into the ocean. That's what it's trying to do. But a lot of times as it's depositing that sediment, the land is changing, so it just becomes more difficult and it finds a different path. And that's kind of how it ends up looking like these fans. So wind is going to be a huge contributing factor in the formation of sand dunes. That's kind of what we talked about. Wind forms sand dunes. And then water is going to form canyons, V-shaped valleys, and deltas. Okay. Ice is going to form U-shaped valleys. So that's going to be an important thing for you to remember. Weathering, erosion, and deposition play factors in every one of the landforms that we talked about. But the different wind, water, and ice kind of dictate how the landform will look. So wind is going to shape these huge sand dunes. Water creates canyons with steep sides or valleys, very narrow valleys. Water helps in the formation of deltas. And then ice really carves out these very beautiful U-shaped valleys that are very picturesque. So I hope that this kind of helps you out, and we'll be seeing you. Thanks, guys.